Assalamualaikum warahmatullahi wabarakatuh. A very good day to all of you out there. So in this practical, I'm going to just go through, not quickly, but in a very succinct way, in this practical of stereochemistry and its application to drug molecule. What we're going to do today is we're going to use molecular models from the practical labs. So our objective first is to construct simple alkane and cyclohexane 3D model from 2D chemical structure. 2D is a flat structure. The 3D is you can see it occupying the space. How do you confer or give an absolute configuration? How do you figure out the absolute configuration of a chiral molecule? And usually is actually given by this Kahn-Ingold-Prelog rules. Is more precise than a simple plus or minus arbitrary configuration given by Emil Fischer for the glyceraldehyde. So you can actually identify a molecule through its R&S convention. So let's do one on 2-chlorobutane. This is an example of absolute configuration. I have here on my molecular set, let me just put this on the table, align all this together. I won't be using all of these, but I just want to show you what they represent, the elements or atoms they represent for this model. There's some few things in here. Let me just go through quickly. What are these? These, if you put it this way, you can actually, it looks like a planet, a solar system in a sense, not as a round thing, but as a solar system. So we have it here, pretty much all that we need, do we? Okay, more or less. So here we have the atoms. You have hydrogen, we have carbon, this hydrogen, we have carbon, and then we also have the this is oxygen atom. Okay, just bring it closer. This is oxygen atom, and then this is, I think, is nitrogen, and we have this, I think, chlorine, and the smaller of the same size but different color would be this purple one is, I think, is iodine or bromine. It should be bigger in reality, but that's fine. I think. Oh, is this bromine? I guess this orange one. So this is chlorine. I think this is bromine, and this is iodine. Okay. We won't be using this except for chlorine. So we need a chlorine, and then we don't need this. Do we need oxygen? We don't need oxygen. So what we need for this 2-chlorobutane, we need a hydrogen. We need this is carbon, and then we need chlorine, and we need these two bonds. This represent a single bond, okay, and this represent a double bond. Is usually used together. We'll have a look later. Yeah. Okay. Let's do then. Let's construct a model. Let's prepare a model of 2-chlorobutane. So this is a 2D model, and now we're going to make a 3D model. So what we have first, the way I approach this is I would see the number of carbons. So how many carbons do we need in this case? So I need 1, 2, 3, 4. So butane, there are 4 carbons. Let's arrange it together. 4 carbons, and then that's butane more or less. and let's just arrange it according to the structure, and then one chlorine here because it will sort of follow the tetrahedral structure. Okay, and the rest we need the hydrogen for that. So but we'll do the framework first, which is the 4 carbons all linked up with a single bond. So we'll take the single bond, we just push it in. Okay, single bond again, gonna push it in. Single bond again. Okay, and then okay. So because of the way carbon is arranged, there are 4 connection to each one. So the way it's arranged is it looks like a zigzag or a double. Yeah, they were. If you have another one, it looks like a W here. Okay, and they are free to rotate in a sense. They can be like this. They can be, because it's a single bond, you can actually rotate in any way, more or less. Okay, can be this way as well in a solution. It can be, if you see later on, it can be in any way. This is that way. There is another way. Yeah. So this is one. This is to show that is having a single bond around here. It makes this compound to be quite flexible. Okay, we have done that. Now we're going to connect the carbon to chlorine because of 2 chlorobutane. So 2 chlorobutane, this is 1. So I'm actually quite wrong here. So 2 chlorobutane, if you want to start from the right, it is 1, number 2. This is 2 chlorobutane. So I'm going to shift this single bond to here. All right. So that's more or less 2 chlorobutane without yet the hydrogen. So that's 2 chlorobutane. Okay. I'm gonna now put in the hydrogen to make it appear more complete. So bear with me. I'm gonna push in all the single bonds. This would be a methyl group. We have CH3. It's the N, and that will be the same thing as well. So this is how you transform a 2D molecule into a 3D molecule. And if you see as well, by now I think it should start to appear that these start to have a specific configuration. Yeah, they can't be too close together because they will repulse each other. The electron clouds here will repulse each other. And when we now add, I have all the single bonds here except this one. Let's just complete the whole thing. And now we're gonna add in all the hydrogen atom to the molecule, to this molecule. Okay, so that's the methyl group. You can see now. I'm gonna add the hydrogen, complete the Christmas tree decoration on by adding hydrogen to the molecule. Then the last one would be adding this one on the CH2. Yeah, CH2. All right, and one more here on the second position. Okay, so now we have a structure. I'm going to push this away so that it's clearer. We have a structure of a 2 chloro. So this is chlorine. So 2 chlorobutane. So butane means 4 carbon. There's 1, 2, 3, 4 carbons here, and it looks quite nice at the moment. It looks like a caterpillar with a head in the middle, and you can see as well, because of the single bond, it has some flexibility around the bond, so you can actually adopt this kind of conformation. Can also go really like that way, which is D. Just now I showed you. Can go this way, the other end. Yeah, these can rotate as well. The methyl group. These also can rotate. Yeah, but you can't go this way basically. Otherwise, you have to break the bond. Yeah, and yep. Can go, if it is down here, you can go up, or you can go this way, you can go down that way. So it's quite flexible.